Happy day, YouTube. My name is John, and this is my channel, The Intermancer. I have been doing some interesting things with AI, some things that I find interesting. I hope that you find them interesting also. So let me show you what I've been working on. In previous episodes, I've been doing a lot of live coding, and I'm definitely going to get back to that. But I have decided to take a step back from the live coding because, as I've shared, this whole genetic algorithm framework that I've been working on here is something that I've been thinking about for a very, very long time. And so I have the design in my head, full cloth. I know where I'm going with this, but I haven't taken the time to describe that. I wanted to get moving. I wanted to get building. And so I didn't lay out the full design before I started to get moving. It helps that I've been taking this context first approach because that encourages me to write down design considerations so that they get implemented by the AI correctly. But it's finally time for me to actually get involved with writing the design down. So something I've done is I've created this new branch here of create roadmap, and in my AI context directory I created this design MD. Now I'm going to read it out loud because this is short. This is a pretty short document. I'm not going to read all of the documents that I've been working on, but I'm going to read this one out loud. Gaia-F is a genetic algorithm framework. It works on time series data to look for algorithmic patterns in the data. The time series data is modeled as a series of data quanta. Each data quantum contains a set of data points that represent the data stream at a point in time. Algorithms are modeled as organisms. Organisms have chromosomes, chromosomes have genes. Genes represent a single operation on the data quanta. Evaluation. An organism is evaluated by feeding it a series of data quanta. Each data quantum is fed to the organism. The organism passes each data quantum to each of its chromosomes, which in turn feeds the data quantum to each of its genes. Each gene selects one or more data points from the data quantum, operates on that data in some way, and then adds one or more new data points to the data quantum, which is then passed down the chain. After the data quantum has been fed to an organism, it will have the original set of data points as well as new data points, at least one new data point for each gene in the organism. An evaluator then scores the data quantum in some way. The next data quantum is fed to the organism, and the evaluator scores that one as well. After all of the data quanta in the time series have been fed to the organism, it is given a score by the evaluator. An experimentation. An experiment has the following steps. An organism repository is seeded with organisms. All of the organisms in the organism repository are evaluated by a single evaluator. The score for each organism are stored in a score repository. That should be an is. The experiment selects two organisms from the organism repository, breeds them, mutates the children, evaluates the children, and stores the children in the organism repository and the scores for the children in the score repository. This process continues for as long as the experiment is intended to run. Interpretation and example. As an example, consider the time series data of open, high, low, and close prices for the Dow Jones Industrial Average Index. This is a well-known set of data, and many people try to find an effective way to model this data since that would presumably enable them to make a lot of money in the stock market. We can evaluate an organism by feeding it each of the data points in that time series. After the organism consumes a data quantum, the data quantum will have many more data points than the first four it was initialized with: open, high, low, close. If we interpret the last data point in the data quantum as a prediction for the open price in 2 days, and then feed the organism 2 more data quanta, then we can start evaluating the data quanta by the absolute difference between the first data point in the data quantum and the last data point in the data quantum that came 2 times previous in the series. Okay. That is my first shot at a design document. you can see it's not great. It doesn't have a lot of information. It doesn't talk about where I'm going. It's too familiar. It doesn't do a lot. What I wanted to do was feed this document to Claude and ask it to give me a better design document, because I put a lot of information in all of these other context documents that you've been seeing me work with. One exciting thing to keep in mind is that last week Claude 4 came out, both Sonnet and Opus models, and I had just started this, but I hadn't gotten very far on it. And then when those two models came out, I said, okay, got to get this done now. And I also wanted to compare the two models in how they give me a better design document. Further, I wanted to learn some things about mermaid diagrams. I don't know much about Mermaid. Mermaid's a technology that allows you to describe a diagram with markdown syntax, and then it generates the diagram for you. So we're going to go over all of that now. I'm not going to do it in front of you. I've already done all of this. I'm just going to walk through what my experience was like, because there are some interesting things to keep in mind. First and foremost, I went to the Claude 4 Sonnet model. Sonnet 4 is the smaller, faster version. Opus is the bigger one. And I gave it this simple prompt. And I had done the thing that you've seen me do, where I used this branch for this repo branch of create roadmap branch. And I had initialized my Claude project with that branch so that I could tell it about the most recent versions, and so that any changes, so I can be a good programmer, any changes I make will go into the branch instead of master. I gave it this prompt: rewrite design MD to make it more complete and bring it in line with the other documents in that same directory. Give me 3 different versions to choose from. Now again, I'm not going to read all of this to you. I don't know if I'll include it anywhere where anyone can get to it, because I don't know how interesting anyone's going to feel. And anyone who is really interested in this always has the option of running this experiment yourself. The code repo is public, so you can always take this version of Design MD that I'm using here and ask either the free Claude or ChatGPT or whatever you want to use for what their version of it is. I read through each of these. Version 1, which was comprehensive technical, and does exactly that. It talks about the concept, the data model, the gene, the architecture for how the organisms are put together, and it generally follows the design documents that I've put together. It has some example of processing flow. It's much better than the Design MD that I originally asked it to expand on, and you can see how it brought together information from these other context documents, especially the organic classes, and a little bit from Tech Stack, because it talks about Spring Boot, and you can see that it includes a little bit about the basic arithmetic genes and whatnot. Interestingly enough, after having read through all 3 of these, the one I think I like the most of these 3 is this business-focused one. It gives it enough. I don't need this document to restate everything in my other context documents. I just need it to be harmonious with those documents. And this one really expanded on what I was doing, and it communicated what I'm trying to do with this framework in an interesting way, and in a way that I could see being the core for a business plan later on, because it has some ideas about where the technology would go. I wouldn't take it just the way it is. For example, specifically the way it describes the experiment cycle. In my head, I'm thinking of an experiment cycle that traditional genetic algorithms work on a generational approach, where you create a whole generation of organisms. You evaluate that generation. You select the winners from that generation, and then you do that again. So you generate a whole new generation. Whereas I'm wanting to do something that is more amenable to very broad distribution. So instead of working on a generational approach, I want to take a much more iterative approach where you have a repository of organisms that have been scored, and it selects one from like the top 10 and one from the rest of them, and breeds and mutates and evaluates the children and puts those in place to see if they're better or worse than their parents, or if they're better or worse than others in the repo. Specifically their parents, because I don't want a particular genetic pattern to just utterly dominate the whole repository. But we'll do experiments about that down so far down the road. That's stuff I've been thinking about for a long time. All we're talking about here is using the generative AI and how it helps me to develop these ideas. Interestingly enough, this second version, I used Claude Opus, and it also gave me 3 with the same prompt. I copy and pasted the prompt from the Claude 4 Sonnet, but Claude 4 Opus gave me different documents, different expansions of DesignMD, but I didn't like them as much. And I was surprised by that. I didn't like them as much. It focused too much on just describing the stuff that I had already done without looking and trying to understand what I wanted to do going forward, which is fascinating to me, because you would think that Claude Sonnet 4, the smaller one, would give you things that are less considered. And we're definitely going to see some examples of that in a moment. But in terms of these documents, and I'll have to read through them in more detail, but I've read through all 6 versions, all 6 documents that Claude created as versions of this design markdown file. I've read through all 6 of them at least twice, and I'm pretty sure that I will end up taking this business-focused version 3 from Claude Sonnet 4 and doing a little bit of expansion on that and incorporating that into my code base, because I like this one the most. That's interesting to me in a few different ways. It's interesting to me that I genuinely like the business-focused version more. And it's interesting to me that the Sonnet model versus the Opus model gave me one that I liked. That's not to say that Claude Sonnet 4 is better than Claude Opus 4. Because after I generated these documents, I had another experiment I wanted to run. Mermaid is a relatively new technology. I call it relatively new because I didn't know about it up till like a few weeks ago. I heard a buddy of mine describing it on his blog, and then he was talking to me on the phone about it and mentioning he used it. And what Mermaid does is you can describe a diagram using a similar markdown syntax, and it generates a diagram for you. And Claude, the previous version, Claude version 3 Sonnet, when I'd asked it what it can do in terms of image processing and diagram representation, it had told me that it could create mermaid diagrams, and that was like one of the 4 or 5 things that Claude was telling me it could do. So the mermaid diagrams were big in Claude's own conception of its own toolbox for generating diagrams. And so I was like, okay, this is interesting. We're gonna play with this. So I did. After I prompted for the design document, I said, okay, based on the documents in the Gen AI context directory, so those same documents that it was using to create this design document, create a mermaid class diagram of all the Java classes that are explicitly described. So nothing that is projected or imagined, try not to hallucinate, just if it's described in these documents, the ones that you already have, create a diagram that includes those. It says, hey, I'll analyze the Gen AI context documents, identify all explicitly described Java classes, and create a comprehensive mermaid class diagram. And it started putting out some stuff that didn't work. Did not work. And I don't know why it didn't work. I just know that I gave it a prompt. It said, here you go. And it gave me something that didn't work right out of the gate. And then it described the thing that it had generated, but it didn't work. So I asked it, what is the syntax error in the generated document? Now let's see this document. It says, looking at the mermaid class diagram, I can see the syntax error. In mermaid class diagrams, abstract methods should be indicated with italics using star after the method name, but the syntax I use is correct. I don't even think that's correct. The error is in these lines, operation, blah, 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 blah. So here, let's see. So it's saying it's in Gene, and it's got this copy of Gene. The star should come immediately after the method name without a space, and it should be used to indicate abstract methods, not return types. Let me fix this. Okay, so it's got those. It gave me version 2. Version 2 to fix that syntax error. And at this point, I didn't know anything about Mermaid. Okay, at this point in my experiment, I was just saying, okay, I don't know anything about Mermaid. This is all new to me. You do you, Claude. Give me a Mermaid diagram since you said you could. So it gave me version 2, and version 2 still has a syntax error. It's like, huh, okay. The syntax error, it said, I fixed that, so let's look at the code. In Gene, it didn't fix it. Look, the corrected syntax is this, but in Gene it did this. It has the same diagram, same syntax here. Look at that. It said it fixed it, but it didn't fix it. What the heck? Version 2, pretty much the same thing as version 1, even though it told me what was wrong with it. Okay. And again, at this point in my journey, I still don't know anything about Mermaid. I mean, now I do, because I've gone through all of this. I'm sharing my adventure with you, and at this point in the adventure, I knew nothing. So I'm just trying to vibe code. I hate vibe coding. I hate the term vibe coding. I'm not going to do vibe coding. Vibe coding is where you just say, hey, AI, here's something I want a program for, generate the program. And if you have an error, you just give it the error. You say, here's your error, fix your own error. So that's what I was doing. There's still at least one syntax error. It's all in you, so you know what it is. You're right. Let me look more carefully. I believe the issue is with the generic type notation. Now at this point, I hadn't opened the syntax because I wasn't even reading really what it was saying. I was just trying to say, hey, you got an error, keep going. So version 3 comes and it's still not working. Womp womp. Let's see, let's look at the syntax here. Did it fix those in Gene? Still didn't fix that in Gene. But it identified this double bracket thing for interfaces. Interface. And it didn't fix that. Angle braces for generics need to be escaped or written differently. Okay. So I guess that's what it did here. Let's see. Version 3 has these tildes around data point. Let's look at version 2. Look at the syntax. It does generics with tildes. It doesn't use the... it's obviously lost. And I'm going to cut to the chase because I kept going back and forth with it saying, hey, do they support? At this point, I started asking. I think I'd looked at the syntax. And I had taken all of this text here, and I found that you can go to mermaidchart.com, and you can put it in, and it will give you it will analyze what you have and see it had this problem. It said this didn't work here around the data quantum consumer, which it was calling a class at this point. This is an old version, but it was calling out the data quantum consumer and saying I had an error right there. So I had gone back and I'd said, okay, data quantum consumer, are you sure you need this interface? And I asked to do mermaid diagram support and interface declaration. You're right, it doesn't. So let me give you this interface with the stereotype, right? So it gave me this version. Still doesn't work. Holy cow. What? You're killing me. You're killing me, Claude. You're killing me. You still have your star at the end of these types. You didn't fix that. You just told me about the interface. And, oh, okay. It at least fixed that. It at least fixed that. And when I put that into the mermaid chart, it immediately told me that I had the same problem with this abstract here on Gene. Okay? So at this point, I'm starting to learn a little bit of mermaid just by going back and forth between the Claude interface and this mermaid chart representation. And you'll notice here that on Gene, it didn't have a problem with this operation having double star. Let's see, Gene. Gene, abstract, copy of, double. See, these are italicized, so it apparently was okay with the star at the end. So I think Claude was lying to me about the star needing to be right after the method name and didn't go after the type, because look, it represented things correctly here by making this operation and copy of methods. These are both abstract methods, which is what makes this an abstract class. So Claude was so lost. Claude was so lost. You still have abstract Gene class. It's still an error. You're right. Let me give you that. Oh, I'm still doing it. I'm still doing it exactly the way that I said I wasn't going to do it, that you told me I needed to fix. And so I finally say, version 10 of the diagram, you still have abstract class Gene, and you do not have the abstract stereotype. Please make that change, and only that change. And so finally, version 11, going back and forth, where I finally said, just make this one change and don't make any other changes, gave me something that worked. And let's look in. Again, as with the one on, why is it? Okay, I don't know why it's got that little Google Drive thing here. But let me zoom in a little bit more. You can see it has the operation and copy of methods are correctly described as abstract by their italics. So this actually looks great. This looks great. But it took 11 tries to get there. Now then, once I had a working version, I noticed that there is a whole lot of nonsense. A whole lot of nonsense here. Let me go back. Look at all these arrows. I wanted all these arrows to go away because there's too many arrows. So once I had a working diagram, I said, excellent, you finally corrected that error. Now remove all the associations between basic cedar and the concrete genes. Only remove those associations. Keep everything else the same. By this time, like I said, I'd been learning a little bit of the mermaid syntax. And specifically, I wanted to get rid of this stuff. That's what I was telling it. Any associations between basic cedar and concrete genes, remove those. Only remove those associations. Keep everything else the same. It gave me version 12, which looks a lot better. But it took a while. And I had to learn some things about mermaid to get it to work right for me. Now, I want to contrast that with Claude 4 Opus. And as I shared before, Claude 4 Opus gave me 3 versions of that design markdown file. And they're good. They're not bad. They're decent. But I liked the ones that came from Claude 4 Sonnet better. And this business-focused one is probably the one I'll keep after I make a few changes. That was interesting to me. However, when I gave Claude 4 Opus the same prompt about generating a mermaid class diagram, copy and paste from my chat with Claude 4 Sonnet. Claude 4 Opus gave me a good one in one shot. It works. It worked fine in one shot. It's a little bit different, but just a little bit different. Look, it's got the interface. It's got the abstract on the gene. Oh, look, this is interesting. It's got these hash maps. I guess these hash maps are how it calls these methods to be proper abstract methods, which forces gene to be an abstract class. So Claude 4 Opus really does seem to be able to generate mermaid diagrams much better than Claude 4 Sonnet. I found all that interesting. Hopefully you fine people found that interesting also. I'm still going to be doing a couple of things on this front off camera. I'm going to update the Design MD with the version that I like, and I'm going to clean it up a little, make a few changes so that it's more in line with what I want. And I'm going to push that up to the repo, and I'm also going to change the document name a little to Design and Roadmap, because there were some roadmap elements in that document, and I want to expand on those. And I want to get that experiment cycle described correctly. I'm going to do all of that off camera, and I don't know if I'll make a video about the results, but soon, the next thing I will be making live coding videos about is adding mutation in everything. And I'm hoping that I can get mutation handled quickly. I've been learning some things about how to appropriately use these documents to refactor existing code. So we'll see if my learning helps me do it better. And until then, thank you for your time. I'll talk to you soon.